The Fermi Paradox. Where are all the aliens? There are more stars in the universe than grains of sand on every beach on Earth. Billions of galaxies, trillions of planets. And yet, in all that vastness, we've never heard a single voice. No signal, no message, no proof that anyone else is out there. If the universe is this big, this old, and this full of planets, where is everybody? This is the Fermi Paradox. In 1950, physicist Enrico Fermi was having lunch with colleagues, casually discussing UFOs and alien life. The conversation was light, almost a joke. Then Fermi paused and asked one simple question. Where is everybody? It sounds simple, but that one sentence turned into one of the biggest unsolved questions in science. Fermi wasn't asking if aliens exist. He was asking why, if the numbers say they should exist by the billions, we haven't found a single trace of them. No radio signals, no spacecraft, no lights in the dark, just silence. To understand why this is such a strange silence, you need to understand the scale we're talking about. Our galaxy alone, the Milky Way, contains over 100 billion stars. And the observable universe contains more than 100 billion galaxies. That means there could be more planets out there than there are grains of sand on every beach and desert on Earth combined. Many of those planets sit in the habitable zone, not too hot, not too cold, with the right conditions for liquid water. And the universe has existed for over 13 billion years. Some stars, and their planets, are billions of years older than our own solar system. Which means, if life can happen once, it's had an enormous amount of time and space to happen many, many times. In the 1960s, astronomer Frank Drake tried to put a number on this. He created an equation, now called the Drake equation, that estimates how many communicating civilizations might exist in our galaxy right now. It multiplies things like how many stars form each year, how many of their planets could support life, and how long a civilization might survive and keep sending signals. Depending on which numbers you plug in, the answer ranges from almost none to millions. Scientists don't agree on the exact number, but almost everyone agrees on one thing. Statistically, we shouldn't be alone. And that's the paradox. The math says the galaxy should be buzzing with life. Old stars, countless planets, billions of years of head start. So somebody, somewhere, should have already explored the galaxy, or at least sent a signal we could catch. But when we point our telescopes at the sky, nothing. No radio chatter, no megastructures, no visitors. Just an enormous, silent universe staring back at us. So where is everybody? Scientists have proposed dozens of possible answers. The simplest one, distance. Space is almost incomprehensibly big. Even traveling at the speed of light, a signal from the nearest potentially habitable planet could take years, decades, or centuries to reach us. And the same time again for a reply. Civilizations might be out there right now, but so far away that their signals haven't arrived yet, or ours haven't reached them. In a universe this size, two civilizations could easily exist for millions of years and still never cross paths. A darker idea is called the Great Filter. It suggests that somewhere along the path from simple chemistry to a spacefaring civilization, there's a step that's incredibly difficult to pass. So difficult that almost nothing makes it through. Maybe that filter is behind us, and we got lucky. Or maybe it's still ahead of us. A challenge every advanced civilization eventually faces and fails, whether through resource collapse, catastrophe, or something we haven't even imagined yet. If the filter is still ahead, the silence in the sky isn't comforting. It might be a warning. Then there's the zoo hypothesis, the idea that advanced civilizations already know we're here, and they're deliberately staying quiet. Maybe they're observing from a distance, waiting for us to mature as a species before making contact. It sounds like science fiction, but some scientists take it seriously. If a civilization is thousands or millions of years ahead of us technologically, hiding their presence from a species like ours might be almost effortless. Another possibility. Maybe we're rare, truly rare. Maybe the exact combination of a stable star, the right kind of planet, a protective magnetic field, and billions of stable years is far less common than we assume. Under this idea, sometimes called the rare Earth hypothesis, complex life isn't a cosmic certainty. It might be closer to a cosmic accident. Or maybe the timing is simply off. Civilizations might rise and fall in short windows compared to the age of the universe. A species could reach the stars, thrive for a few thousand years, and vanish, long before we ever evolved to look up and notice. In a universe 13 billion years old, we might just be looking at the wrong moment. Nobody knows which answer is correct. Maybe it's a mix of all of them. But the Fermi Paradox isn't really about aliens. It's about us. It asks how rare our own existence might be and how careful we might need to be to keep it going. So next time you look up at the night sky, remember, every star up there could be hiding a planet, a story, maybe even a question just like ours. And maybe, somewhere out there, someone else is asking the exact same thing. Where is everybody? So, what do you think? Is there alien life out there in the universe? Leave your thoughts in the comments below. And to make sure you never miss another fascinating video about the universe, subscribe to our channel and share this video with your friends.